further ado, I'd like to welcome Daniel Sanchez Garcia, who's going to do the first in a new series of education webinars on building simulation best practice. And Daniel's going to be talking about using adaptive set point temperatures as an energy saving measure in EnergyPlus. This webinar is part of the overall mission of the CIBSE Education Committee, which I chair. Part of what we do is to try and identify education and training needs, and that's not just about what's happening in academia, but it's also about what's needed in the private sector and in government. And we initiate, develop and encourage, sometimes we coordinate new education materials and methods, and we offer training sessions like this, and importantly those sessions are open to members and non-members alike, and the recordings are made available openly as well. And so we have a standard format for this, which is that shortly I'll ask Daniel to do his presentation, and then afterwards we'll do questions and answers. So we won't be answering questions as we go through the presentation. They'll all be taken at the end. You're very welcome to use the question and answer box as we go through the presentation, though. Pop those in there and then I will put them to Daniel at the end of this. And we will hopefully have a very interesting discussion. Just before we get to that though, I'd like to ask you a couple of questions. The first one is, which of the following best describes the role in which you use building performance simulation? This is all about us as an education committee trying to get a better understanding of who the audience is and what your interests are. So do please use the code at the top. You can join at menti.com and let us know who you are in the sense of what type of use you make, so that we can make sure that we understand whether we're meeting everybody's needs or whether we need to consider other approaches as well. So if you've just joined, and there's a couple of people who have just joined, you can join Mentimeter at menti.com and then use the code to just let us know your professional role and how you use building performance simulation. So that is great. Thank you. Glad to see so many answers. And a really interesting spread here, perhaps slightly different to some of the other seminars which we have done, which have perhaps been a little more academic focused. So I'm going to move on. I've got one more question, which is, where in the world are you based? So please do just pop your answer into Mentimeter and let us know. So there's somebody who's got up very early or is on holiday in joining us from Texas, and a really good spread there across the world, which is really great to see. So thank you very much for that. I've got another question I'll ask you at the end, but that's enough from me for just now. And what I'd like to do now is just to hand over to Daniel and ask him to get started.
Thank you, Pamela. Thank you for this opportunity, and well, I am so excited to be speaking here. So if I may, I will share my screen to start with the presentation. Okay. How can I hide this? I'm not sure. Well, anyway. So in this webinar, I'm going to talk about the usage of adaptive set point temperatures as an energy saving measure in EnergyPlus. First, I'll present the research background, the developments of the adaptive comfort control implemented model, and the adaptive comfort control implementation script. I'll quickly present the references, and finally, we'll put it into practice with a Jupyter notebook. So the research background of the adaptive set point temperatures started back in 1998 when Richard Didier and Gail Brager first published their adaptive comfort regression model, in which they used the outdoor temperature as the independent variable. They found that although air-conditioned buildings had little to no adaptation impact, naturally ventilated buildings yielded a strongly adaptive comfort model. Due to this, the DR and Brager, and later the Australia Technical Committee 2.1 in charge of the Standard 55, came to the first conclusion that adaptive comfort models were only useful in naturally ventilated buildings. Nevertheless, using the Australia Global Thermal Comfort Database 2, Thomas Parkinson reanalyzed the original Australia adaptive model in the 2020 publication. As a result, a consistent adaptive model fitted remarkably well across all building types when indoor temperature was used instead as the independent variable instead of the outdoor temperature. This prompted to reevaluate the adaptive comfort models in air-conditioned and mixed-mode buildings. Therefore, what the 1998 research thought to be an adaptation to the outdoor environment was actually a correlation with the indoor climate, which in turn was connected to the outdoor climate. Therefore, this leads to think it is possible to achieve thermal comfort by using set point temperatures based on adaptive comfort models, or shorter, adaptive set point temperatures. So we started to work with these adaptive set point temperatures and developed a framework we called ACCIM, which stands for Adaptive Comfort Control Implemented Model, in which the indoor environment was heated up or cooled down so that operative temperature fell within the adaptive thermal comfort zone, and the energy needs were remarkably smaller than those from typical set point temperatures, such as those from ISO 7730. You can see here the difference between the static set points at left-hand side that may change from heating to cooling season, and the adaptive set points that changes daily based on the temperature of the previous days. To provide an idea of the potential of energy savings, a study carried out for Seville's climate shows a roughly 75 and 55% energy savings for cooling and heating, which resulted in a roughly 70% in total energy demand in present scenario. Considering the already superseded scenarios included in the assessment, in the fourth assessment report of the IPCC, this total energy saving was reduced to roughly 60% in year 2080. In this respect, the energy demand from adaptive set points is calculated with EnergyPlus, but this followed a manual process that involved given a building energy model, the previous calculation of the values for the adaptive set point temperatures and the selection of the scheduled compact objects, the selection of the EPW file to lastly run the simulation and repeat the process one by one after changing the set points and EPW file. Therefore, in order to automate the whole process, I developed a script for energy management system called ACCIS, which stands for Adaptive Comfort Control Implementation Script, and later a Python package called ACCIM after the framework to implement ACCIS. So this is the most simplistic version of ACCIS. In this EMS script, the adaptive set point temperatures take the values of the adaptive comfort limits, whose calculation is based on the prevailing mean outdoor temperature. Therefore, an EMS sensor named PMOD is needed. Also, we need to override the values of the scheduled compact objects used for the set point schedules, which is done by two actuators named ACST_value and AHST_value. Then an EMS program and a program calling manager objects are added, which controls the calculation of the values and setting of the actuators depending on the PMOD sensor with 2 if blocks for the heating and cooling set point temperatures. So the program can be read as follows, considering the ASRAE 55. If PMOD is between 10 and 33.5 Celsius degrees, which means the applicability limits are met, then the adaptive cooling set point temperature value is set to 0.31 times PMOD plus 17.8, which is the neutral temperature, plus 3.5, which denotes the upper comfort limit for 80% acceptability. Therefore, all those red points, which are discomfortable hours, will be cooled down into the adaptive comfort zone. But what happens beyond the applicability limits? We wanted to make all hours comfortable, so some set point had to be used. In this case, the set point temperature is horizontally extended. So back in the code, for PMOD values below 10 Celsius degrees, 10 is used instead of the PMOD, and therefore, in the figure, the set point temperature is horizontally extended. On the other end, when PMOD is above 33.5 Celsius degrees, 33.5 is used instead of the PMOD the same way, and the set point temperature is also horizontally extended. Then the if block ends, and the one for the adaptive heating set point temperature begins following the same logic, but with negative 3.5 instead of 3.5. And all the temperatures below the lower comfort limit are heated up into the comfort zone. The research related to ACCIM and the Python package ACCIM has been published in 2 open source research papers, which you can see on the left, titled A Detailed View of the Adaptive Comfort Control Implementation Script, the Capabilities of the Automation System for Adaptive Set Point Temperatures in Building Energy Models, in the journal Energy and Buildings, and Computational Approach to extend the air conditioning usage to adaptive comfort, comfort control implementation script in the journal Automation in Construction, although the code in this has already been superseded. On the right, you can also see some papers in which adaptive set points have been applied, most of them to reduce energy consumption and energy poverty levels. All right, so now that the adaptive set points have been explained, let's put it into practice. First of all, these requirements must be satisfied. Firstly, the IDF we're using is in version 23.1. Therefore, we need to have installed EnergyPlus 23.1 in the default path in disk C. Secondly, Python 3.9 must be installed. ACCIM won't work with Python 3.10. Besides, the user should tick the checkbox at Python 3.9 to path at the installation menu, and the path length limit must be disabled. Thirdly, Jupyter Notebook must be installed. To do so, once Python is installed, open a CMD dialog and execute pip install notebook. And finally, ACCIM must also be installed, of course. We're going to work with version 0.7.1. So the user can install this version by opening a CMD dialog and executing pip install ACCIM == 0.7.1. All right, so I'm going to share my other screen in a minute. This one, fine. And I'm going to, okay, let's run this Jupyter Notebook, okay? Let's open the side packages of your Python installation folder, and here we have ACCIM. So let's open ACCIM, sample files, Jupyter Notebooks, and here we go. This is the full example for the CIBSE webinar. Let's copy it and paste it somewhere else. So here, for example, sorry. Here it is. So let's open this. And now let's open CMD dialog here, or PowerShell. So let's run Jupyter Notebook, hit enter, and internet browser will open. So here we go. This is the Jupyter Notebook. All right, so this Jupyter Notebook, I will usually need 2 or 3 hours to properly explain all the steps and properly explain all the arguments in this Jupyter Notebook. So given we have roughly 30 minutes, so you can expect this is going to be quite intensive. So let's get to the point. Well, this is going to be an example of adaptive set point temperature simulation. Okay, we're going to run simulations using adaptive set point temperatures based on the Brazilian local comfort model developed by Ricardo Forgerini Rupp. Here you have the reference. And we're going to analyze and visualize the results. So I'm going to clear our outputs, and well, let's run this cell. So the building energy model is a simple to some model tongue design builder with all parameters by default. So we only set the natural ventilation to calculated and allowed natural ventilation in the HVAC tab for the 2 zones. So this is the steps of the procedure we're going to carry out. First of all, we're going to pre-process the data. That is, we're going to implement the adaptive set point temperature, or well, implement this, which is basically the same. We're going to prepare the EPW files. Then we will run the simulations, and then finally we will visualize and analyze the data. Here you have some useful links, such as the web repository, the documentation, and the Python and the project at the Python package index. So first of all, let's apply the adaptive set point temperatures. The ADFs we have here is just one. It's called test model. And well, there are 2 methods basically to apply the adaptive set points. Just this one, which is the simplest one, is just 2 lines of code, or the longer one, which is this one. The main difference is that in this one we're specifying all the arguments we need. All right. If we don't specify them, and therefore we run this code, ACCIM will ask us to enter the required information in the Python console. So let's run this, and in the meantime, I will explain the most relevant argument for this for this study. So comfort stand is set to 15. This is used to select the comfort standard or comfort model. So why is it 15? So let's have a look at the documentation. And here we have the full list of set point temperatures. We can see this also in the HTML. And here you have all the possible settings for the adaptive set points. And if you scroll down, you can see the number 15 is the Brazilian model for naturally ventilated mode. So let's continue. And well, CAT is for category, that is the acceptability levels, which is set to 80%. Conf mode is used to control the behavior of the set point temperatures. That is, whether the set points are static or adaptive, but the behavior may change when the applicability limits are not met. So in this case, we're going to use 0, which is the static set points based on the Brazilian building technical code, and 3, which is the adaptive comfort model, the adaptive set point temperatures. And when the model is not applicable because of the applicability limits, then the set point temperatures are horizontally extended, as we saw in the presentation before. And well, finally, this HVAC mode is, we're requesting here 1, which is naturally ventilated, and 2, which is mixed mode. So here ACCIM will make a brief presentation and will kind of log all the actions it is performing. So if we scroll down here, we can see here these are the 4 IDFs we have generated, output IDFs, which you can see. These are, the name is the input IDF, followed by all the information we have entered, separated by the square bracket, a square bracket character. All right, so let's print. These are the output IDFs we have generated, and the class ADACTIS, which is what we run, has some internal variables we can inspect and might be useful for you. So the most interesting ones are input IDFs and output IDFs. So let's have a quick look at this. Let's have a look, for example, at input IDFs. It is a dictionary which contains the name of the input IDF and the epi.modelator.itf class instance generated for this purpose, to apply the adaptive set point temperatures. So if you don't know EPI, you should check it out. It is an interesting and quite powerful Python package to, well, it is a Python parser for EnergyPlus building energy models for IDF files. So for example, let's have a look at all the scheduled compact objects we have in this input IDF, right? And you can see them. And now let's have a look, for example, at all the energy management system program objects, but there are none. All right, this is an empty list. So now let's have a look at the other internal variable, which is the output IDFs. If we run this, we can see it is another dictionary, but in this case, it has the file name and the epi.modelator.idf class instance of all the 4 output IDFs we have generated. Okay, so let's do the same, but we're going to read the first one. And we're going to see the energy management system program objects we have. Well, in this case, since we added the ACCIM, which is an EMS script, we can see there are some of them. So the next step is that we generated 4 IDFs, but we do not need all of them. So we're going to remove this one just to speed up a bit the simulations. And well, this is the static set points with naturally integrated mode. All right, so let's remove it. And these are the remaining 3 IDFs. Okay, next step, let's prepare the EPW files. And this is done by using the class rename EPW files. The EPW files we have are these 4. So now we're going to rename them. We want them, the new name, to follow the pattern country underscore city underscore RCP scenario -year. But why is that? Because later when we run the simulation and read the CSV files, we will be able to analyze them considering the fields country, city, RCP scenario and year as categorical variables. All right, so let's remove them with this cell here. By the way, rename EPW files. This class will use the coordinates of the EPW file to make a query to OpenStreetMap, and based on that, it will get an address. All right, but in this case, we're doing this a bit simpler because we're saying, okay, look, Chapeco, look for Chapeco in the original EPW file name, and if you find it, set Chapeco as the city field. All right, and well, let's run this. And now it is saying this is the previous name and this is the new name. If these are fine, well, you can hit enter. Otherwise, you can enter the IDs. So these are correct. If you want to exclude some of them, again, enter the ID, but these are fine. So let's move on. So, do you want to copy and rename them? Yes, we want. Okay, so if you get an error, an SSL certificate verification error, well, I haven't found a safe way to avoid this error. So in this case, you should have to either rename them manually or using some Python script, such as this one, or not renaming them and using the original EPW file name. So the main difference is that you won't be able to analyze them based on these 4 fields for country, city, etc. So in this case, we're not running this cell, and so let's skip it. And so these are the 8 EPW files, the older and new ones. And well, these are the new ones. And let's move the older ones to the backup folder we have done. All right, so next step, the simulation using run EP. So we have these 3 IDFs and we have these 4 EPW files. So run EP will run simulations using all IDFs and all EPW files. So we will get, in this case, a total amount of 12 simulation runs. Okay, so let's run this. And well, this is the name of the resulting CSV files and other files resulting from simulation, which you can see it is the output IDF file name followed by the EPW file name, concatenated by using again a square bracket character. So while this is, in the meantime, while this is running, I'm going to start explaining the post-processing. So in order to analyze and visualize the data, we need to make a pandas data frame out of the CSVs. We will do this by using the table class. It will concatenate all the CSVs we specify into a single pandas data frame. So let's quickly explain the arguments. First one is dataset. And well, this is a list, the list of CSV files we want to concatenate. Since in this case we are not specifying it, we are omitting it. ACCIM will search all the available CSV files in the folder that meet certain conditions in the file name. Next one is source frequency. And this argument tells ACCIM which is the frequency of the input CSV files. It can be time step, hourly, daily, monthly, and run period. Well, it must be one of the output frequencies we requested when we did the output IDFs. So in this case, we requested only for hourly, and well, here we are. It's set to hourly. Next one is frequency, and this argument tells ACCIM which is the frequency for the resulting data frame. For example, if we enter run period, okay, in this case we're having 12 CSV files, so the resulting data frame will have 12 rows. If we entered daily, the number of rows will be 365 times 12. And well, the frequency aggregation function tells ACCIM the function to be used when the rows are aggregated. It can be sum or min. In this case, we're setting it to sum. The standard output is set to true. This is used to work with a certain range of output variables to avoid some errors. And well, this one is level. So for this argument, ACCIM first tries to detect the hierarchy of zones belonging to blocks, belonging to building. After that, ACCIM will aggregate the output variables into new columns for block and building or building level. Therefore, this argument tells ACCIM which level or levels should address and should be a list containing the strings block and or building. In this case, we're just asking for building level. The level aggregation function tells ACCIM the functions to be used when the columns are aggregated. It can be sum and or min. We are asking for both of them in this case. Level excluded zones. By the way, I'm going to still run the simulations. It is fine. Well, this argument is used to exclude some zone from level computations. So imagine you want to make an average, the average operating temperature of all zones, which are air conditioned, except one which is naturally ventilated. So you might exclude this zone to get a more accurate mean operating temperature. Then you should exclude that zone entering the name here. And finally, we're going to the split EPW file name, split EPW name, and is used to split the categorical variable EPW file, EPW, into multiple columns for the fields country, city, RCP scenario, and year. It is somehow still running the simulation. Not sure why, because it should have already finished. But okay, in this case, I think I'm going to add manually the CSV files that I have previously computed. I'm not sure why is this happening. It should have taken around 5 minutes, but it is still running. So just wait a minute, please. Yeah, here we are. So the CSV files are these ones. Let's copy this and paste it here. Yeah, and place. Okay. So so these are the 12 CSV files. Okay, we should have got from the simulations. And now let's run this cell. So and now we can access the internal variable df to have a look at the data frame. It is still running. Yep, it is still running. I'm not sure why is this. Okay. And well, here you can see there are a lot of rows and just 123 columns. So now let's visualize the data. So we're going to use the table instance we just created, but we're going to use the method format table to filter the columns. So we have here the categorical variables extracted from the file name and all other columns related to the output variables, the EnergyPlus ITF. And we just need these ones, these files, these columns. So we run this, and here we go. We have the same amount of rows. We have only 29 columns. So at this point, you might be confused about what you can analyze and plot. The way to identify the IDFs individually is combining or gathering the categorical variables that make them different. In this case, for the IDFs, these are the conf mode and HVAC mode, as we requested in the ACCIM instance. And in case of the EPW files, the columns related to this are these 6 columns. So EPW city or subcountry, which is city field, and EPW scenario should be enough to identify them. So we can, well, to get a clear view, you can use the method gather vars query, which will provide a list of the categorical variables extracted from the CSV file name that change and therefore can be used in the analysis and the values that this contains. So let's try this. And here we can see that for comp mode, we have the values 0 and 3. For HVAC mode, the values 2 and 1. And well, for city, we have Chapec and Palmas. And for scenario year, we have present and RCP 8.5 2100. So what we are going to do is we're going to combine the values of these two parameters to make them and to identify them individually. So in this case, we run this code and this one. The first one is for the ITFs, which we can see that it returns the ITFs, the 3 different ITFs we have, all right? And in this case, the 4 APW files we have. So considering that information, okay, I'm going to run these 3 code snippets for the figures, because this might take a bit more than expected. But anyway, here, for example, you might expect from these figures some kind of facet grid from seaborne plots or subplots in which there are rows and columns of plots. Okay, so in this case, since in the rows we're showing the values for the city and scenario here, we will have a total amount of 4 rows, which refers to the 4 EPW files. The same for the columns, in which we have combined comp mode and HVAC mode. However, instead of 3, which because of the 3 IDFs, we have only 2 columns. And why is that? Because we requested specifically these 2 columns in the detailed calls argument. All right. So, well, all other arguments are for the to select the data we want to plot. So in this case, the x-axis, this is the column for the x-axis. In case of the data on the y main axis, we need to enter a list which contains a list for every spine we have. In this case, we're just plotting the indoor operative temperature, and we are plotting these 3, which are the adaptive and heating and cooling set points and the operative temperature. We're plotting these 3 columns on this spine. And well, all other, this is the same structure, but using matplotlib color notation. And here we say and rename this subplot title to this. Okay, so this is what we get. And as you can see, this is the naturally ventilated mode. That is, we are not using any set point temperature. And in this case, we are using the adaptive set point temperatures. So we can see here, there are lots of hours outside the thermal comfort zone. In this case, there are apparently all of the hours are outside the comfort zone. And in this case, all of them fall within the comfort zone. In this case, you might think there are no values for the operative temperature, but there are, but they are quite close to the comfort limit, the cooling set point, and we can't see them. So this is the second code snippet is a bit similar, but in this case, we are also plotting the adaptive set point temperatures. The static set point temperatures, okay, which is this column. And we are plotting 2 spines on the secondary y-axis, which are the air renovation and the operative temperature. Yeah, on the main axis, we are plotting the energy. In this third code snippet, we are plotting a similar figure to the first one, but we are plotting the time on the x-axis. So we can see here the entire year. Okay, we can see here how the set point changes along the year. So last step, let's analyze the data. We are going to make some tables summarizing the data and get some columns to compare the results. Okay, so for example, let's see how many comfort hours there are, as well as the impact on energy demand. So we're going to make a new table instance to use the run period frequency. So we will get 12 rows, and we're going to filter the data frame to show only the comfortable hours, that is not considering the applicability limits, and the building total energy demand. Okay, so let's run this. I should have done maybe, oops, not, yeah, now it's running. And let's take a look at the data frame. And here we can see the 12 rows. And well, data is not easy to be read like that. So let's make it a clear view using the wrangle table method and pass the string multi-index in the reshaping argument. Okay, here in the reshaping argument. And let's have a look at this internal variable, wrangled data frame multi-index. So let's run this. And now we can see these are the available comfort modes we requested for the HVAC modes, and all the results for the comfortable hours and the total energy demand. Okay, so now it's better, but we'd like to unstack the variables for comfort mode, the variables comfort mode and HVAC mode. That is, move these to the rows. All right, so let's run again. Let's call the method wrangle table, but let's use the instack method. And well, in variables together, let's add the variables we want to unstack. And well, this dictionary just renames it, searches this string and renames it to this one. So let's have a look. And here it is. We can see, for example, that in the graph that apparently all of the hours were outside the comfort zone, which was Palma's RCP 8.5. We can see there are only roughly 50 hours within the set point temperatures. Okay, so okay, but what if we want to know the heating, cooling, and total energy demand increase or decrease percentage of, for instance, the Brazilian adaptive model using mixed mode compared to the other two combinations? So let's run this cell. We are again calling the format table method to filter only the heating, cooling, and total energy demand. Well, this is the same. We are unstacking. We are using these two variables, but we are using the baseline argument, which is set to this one. Well, comfort mode 3, as we said before, is the adaptive set points, and based on the well, we're working with the Brazilian model, and HVAC mode 2 is for mixed mode. So let's compare this baseline to the others. Okay, we will also compare the others to the baseline. And well, let's add the columns to see the results, the comparison as a percentage and as a absolute difference. Okay, finally we will transpose it and let's have a look. So for instance, we can see the adaptive set points provide reductions in the energy demand compared to the static set points between 19% and 70%, depending on the scenarios and climate zones. So, well, we should not forget we're working with pandas data frame, so we can treat it as a pandas data frame. And for example, we can export it. We can export it to Excel. And for example, let's read it. And here we go. It is the same. Okay. And well, finally, I'm going to run these 3 cells to to leave all the files as they were before. By the way, here you can see on the same folder, which here there are all the PNG files for the figures we have created, and for example, the XLSX file. Okay, so you can take a look here, for example. You can also change the resolution, the DPIs, and well, let's, as I said, let's remove this. Okay, and there we go. We can run again the entire Jupyter notebook. And well, that is the tutorial. I'm done with the talk, with the presentation, and with everything. So I'm going to stop sharing my screen, if I know how.
Thank you very much, Daniel. That's great. It might be as well to leave, sorry, my video wasn't going back on there. Maybe keep sharing your screen. I think maybe some of the questions that people would like to ask might prompt you to jump back a little bit and to answer some of them. So we've had some very thoughtful questions through in the Q&A box. So do please put those in if you have anything that has come up. And I think the first question I would like to ask is sort of paraphrasing a couple of these which are related, I think, which is just to, if you could just explain a little bit about how this builds on the work that's been done previously around adaptive set point temperatures and how you see people using this code and the notebook in their own work. So.
Well, I can't. Well, I think my computer is not. Well, the Zoom application is not. Is kind of frozen, so I can't see the chat. Okay. And well,
that's fine. I think so. I'll just read them to you. But the question is really just how do you see people incorporating this into workflows? How does it allow them to build on the rest of the body of work that's out there around adaptive thermal set points?
Well, I think so far this zone has been always simulation.
Oh dear, I think we have lost Daniel, which is very unfortunate. So I think in that case we will give him another couple of minutes just to see if he is able to return. If not, what we will do is we will do a separate offline Q&A where I can put the questions to him and we can record his answers and we can add that into the video. So do please keep putting your questions forward. I will put them forward to Daniel offline, and we'll include that in the recording if Daniel is not able to rejoin us. I'm just going to share my screen again. I would just like to finish up by saying a couple of you have asked about the recording and where you'll be able to see that. So that is going to be posted on the CIBSE University YouTube channel. So you will be able to look at that. And if you look at that, you can also see all of the other webinars which we have hosted, which is now, I think, around 45 that we've had. So there's a lot of really informative and excellent content on there. And I'd encourage you to have a very good look through that. if you are at all interested in the state of the art in building performance simulation. Now, I said I had one more question, which is related to the topic of future seminars. So we have two more that are scheduled. These are both as part of the urban building energy modelling theme that we've been running this year. The first is Aisha Demir, who's going to be speaking in September about the impact of spatiotemporal resolution on the calibration of urban energy models. And then we have a very illustrious speaker indeed, Tianxing Hong, in November, who will be talking about the opportunities and challenges around urban scale modelling. We have a couple of other sessions that are in the works, so do look out for those. Those will come out on the CIBSE mailing list, and also I'll be posting the details on LinkedIn. We are always very interested in your views about what you would like to see covered in future seminars. So do please take this opportunity to use that Mentimeter link and let us know what you would like to see covered in future seminars. So, hi Daniel, welcome back. I can't hear you just now. What we'll do is we have a number of questions. I'll put a couple of those to you just now, but I think we will probably run out of time for all of them. So what we'll do is, if you don't mind, we'll have a separate little session, just the two of us, and we can record that and incorporate it in the video as well. So I will just, while everybody is answering my question about other topics that people would like to see, I'll just go back to the question which I think I just asked when you had technical difficulties, which was, how do you see people using ACCIM in their workflows, and how does it build on existing work around adaptive thermal comfort?
Okay, yeah. Well, this is certainly a topic that needs more investigation because, well, for example, Stefano Schiavone have done some research based on the use of the set point temperatures, not based on the adaptive thermal comfort models, but quite higher and or lower than usual. And well, the thermal response might vary a bit. So this is something that needs to be more investigated. And well, what is true is that well, this is so far this has been always a simulation-based study, but for example, at the University of Seville, and I think and also other universities around the world have been working in taking this into reality, which is, for example, in the University of Seville, they have programmed a building automation system to use set point temperatures based on the neutral temperature of the adaptive thermal comfort zone, instead of the upper and lower comfort limits. So it is a bit different approach, but it could be extrapolated to address what I have done, for example.
Brilliant, thank you. Can I just ask about the weather data that you're using, and how important it is to have appropriate weather data, and how you go about accessing that weather data?
Well, the weather data, it is important, obviously. Obviously, it is quite important, because if you don't use weather data that actually represents with accuracy the local climate of some zone, for example, well, of course, the calculation of the prevailing mean outdoor temperature won't be that accurate because the PW was not accurate. You know, the PMOD takes it is computed based on the EPW file, and therefore, well, then the results of the simulation will not be accurate.
Mhm.
And yeah.
And so what method do you use for downscaling when you're looking at future weather scenarios?
Yeah, I previously used the world weather generator of the UK Met Office, if I'm not wrong. Well, but that's for the already superseded scenarios, including the fourth assessment report. For the RCP scenarios, I easily download them or generate them using the Meteornorm software. However, there is a I've seen well, I'm not investigated it. I mean, I've not I've seen there is a software developed by somewhere Eugenio Rodriguez, I think, was from Portugal, that can be used to well, in the end it takes an EPW file and it allows to generate the RCP scenarios based on the socioeconomic pathways, and it is free and it is open source.
That's great. I think perhaps we can share a link to that in the next session. So I think that's as many questions as we're going to have time for just now. We will, as I say, do a quick follow-up to make sure that everybody's questions are answered. And just before we go, I would just like to say that there is an opportunity to support the work of CIBSE. Obviously, you're very welcome to attend the all of the webinars, to look at the YouTube channel and so on, but you can also support this work as a supporting member. And there are some benefits to that, including the subscription to the Journal Building Performance Simulation and right to use the supporting member logo. You can find out more about that at cibpse.org/membership. The fees are remarkably reasonable, having remained at pre-pandemic prices. So I would encourage you to consider that as an option. But for now, thank you very much. Thank you to Daniel for that really fascinating tutorial, and thank you to the audience for all of your very interesting questions, which we will continue to work through. Thanks then.
Thank you.
Thanks. Hi, everybody. Welcome back. Apologies for the technical difficulties that we had during the Q&A session when we did the live webinar on Tuesday. So now we are just going to finish off some of the questions that we didn't get a chance to cover. Thank you very much, everyone, for putting those questions forward. It was an excellent presentation and some really thoughtful and insightful questions. So, Daniel, the first question that I've got for you is about how people can use the code. So there's a question coming from one of the participants about whether you are considering adding more comments in the Jupyter notebooks. But I think there's a broader question as well about how do people who want to use the ACCIM package, how do they go about doing that and engage with you about that experience?
Well, thank you for that question. And well, of course, I could do that. I could add any comment lines on this Jupyter notebook to make it more easily understandable. And well, by the way, I'm going to share my screen because there are some other resources you could use apart from the webinar that you can run on your computer. So I'm going to share my screen in a minute. Yes. And well, here, sorry. So here in the documentation, you can see there are some how-to guides. So you can see there are one how-to guide per, to emphasize the use of each the use of each part of the software, okay, of the tool. So here we have, for example, a tutorial to how to use ACCIM, for example. We have here the short version, the longer version, which you can read, and some other uses. And the same, for example, well, here we have also a full example, quite similar to the one that we have that I have showed here in this webinar, but with a different settings and some different things. Okay, and well, same for the others. For example, to rename the EPW files and run EP, and also using the class table and making some graphs and tables and lots of things here. So this is absolutely free, of course, as everything I have explained, and well, it is totally available for you. And I think.
Great, thank you.
Yeah.
To do check out all the resources there as well. What we'll do is we will also, when we post the video on YouTube, we will put a list in the comments on YouTube of the other resources that you can use to follow up. So my next question for you, Daniel, is from a very perceptive participant who has noted that in the initial chart that you presented, the mean outdoor temperature was 25 degrees C, and the internal temperature in the room was originally 31 degrees C, which was then reduced to 29 degrees C. And he is, this participant is suggesting that there might be significant gains which result in such a high indoor temperature. And have you had any feedback from users about that? And possibly also, have you looked at using predicted mean vote evaluations or predicted percentage of dissatisfied about the user experiences in the space?
Yes, I see the point of this question. Well, unfortunately, we haven't had yet the resources to make an investigation on this topic. So we will need to apply these adaptive set points in a climate chamber, study the thermal response, and compare it with the results from other research. And well, this is something we have to do yet. And well, regarding the PMV and PPD evaluations, we actually haven't conducted any because, well, mainly because we can expect this. We can expect this will possibly provide very unacceptable conditions, indoor conditions, from the point of view of PMV, because well, the approach is absolutely different, and to the adaptive approach. And well, that's it, I think.
Thank you. And then one final question, which a couple of participants have picked up, which is about adjusting the set point temperatures. And what they're noting from the charts is frequent changes in set point temperatures over very small periods of time, albeit relatively small changes. And what they're asking is how feasible that is in practice, given what is appropriate for efficient HVAC operation.
Yes, I see. Well, these small changes are actually, the set point changes daily. So the adaptive set points change based on the running mean or prevailing mean outdoor temperature, okay, which is computed daily. Therefore, the set point temperature is the same for the entire day. So I'm not sure because I'm not an expert in plant systems or HVAC systems, and so it is not something I can assure entirely assure. So, but I don't think that should be a problem because we are just setting the set point temperature for the entire day, and then next day it changes. There are just maybe a few decimals. That's the change, but I don't think that should be a problem.
That's great. Thank you very much. So that's the end of the questions. Thank you again, Daniel, for a great presentation. That was really interesting for a lot of people. And thank you to everybody for all of the great questions.
Thanks, Pamela.
Bye.